Welcome back. In the last few episodes, we have looked at the mechanics of an AI coding agent. We have talked about the stateless brain, the harness, the tools, and how context is managed. But that leaves a massive question. What makes one LLM better at this job than another?
It is a surprisingly tricky question. If you look at the industry as of 2026, there are constantly new leaderboards for coding models. A new model comes out. It aces a benchmark testing pure Python or JavaScript generation, and everyone assumes it will be a perfect coding agent.
But that is a trap. The model that scores the highest on a pure coding benchmark can actually be a mediocre, frustrating agent to work with. It might write a brilliant function, but then fail to save the file. Or it might get stuck in an endless loop reading the same error message over and over again.
Right. And that happens because writing code is only one small fraction of what an agent actually does during a session. A benchmark tests how well a model can write a script in a vacuum. An agent, however, is not working in a vacuum. It is navigating a real file system, using tools, and reacting to feedback.
Exactly. To understand why some models excel as agents while others fail, we need to break down exactly what the model is doing on every single lap. We like to think of it as 4 distinct jobs.
Quick, honest note before we dive in. This is an education series, not advice of any kind. We are just two curious people trying to make AI make sense.
And AI moves fast, so everything here is how things work as of 2026, and it will keep changing. Treat it as a map, not gospel. The real learning happens when you go and try it yourself.
So, every time the harness sends a prompt to the model, every single lab, the model has to execute 4 distinct jobs in sequence. It has to understand, reason and plan, act, and finally, govern and communicate.
And if the model drops the ball on any one of those 4 jobs, the entire lap fails, no matter how good it is at generating a Python script. Let's start with the first job. Understand. This sounds obvious, but it is actually one of the most underrated halves of the process.
When we say understand, we don't just mean understanding what the human user asked for. We also mean understanding the environment. The model has to parse the output of the tools. If it ran a command and got a 200-line stack trace back, it has to read that stack trace and figure out exactly what broke.
I have seen models that write beautiful code, but when the compiler throws an error, they completely misread the error message. They look at a database connection timeout and think it is a syntax error. If the model fails to understand the environment's feedback, the next lap is wasted.
Exactly. A great agent model has exceptional reading comprehension. It can sift through a massive wall of terminal output, spot the one relevant error code, and correctly interpret what that means in the context of the code base.
Let's dig a bit deeper into that understand phase, because the context window is often filled with a compacted summary and the raw output of multiple tools. The model has to act like a detective. It has to look at the prompt and separate the noise from the signal.
Yes, and part of understanding is also recognizing what it doesn't know. If you tell an agent to fix the login bug, a model with poor understanding will just start guessing and rewriting random authentication files based on its training data.
But a model with great understanding will look at the request, look at its current context, and realize, wait, I don't know where the login routing is defined. Its first lap won't be writing code. Its first lap will be running a search tool to find the relevant files.
That self-awareness is crucial. Understanding the gap between the goal and the current knowledge state is what triggers the model to investigate rather than hallucinate. It sets up the foundation for the second job, reason and plan.
Right. Once the model understands what is broken and what information it has to decide what to do about it. It has to chart a course.
Reason and plan is where you see the biggest difference between a standard coding model and an agentic model. This job is all about decomposition. If the task is to build a new feature, the model has to break that down into small, logical steps. First, I will read the schema, then I will update the database. Then I will write the API endpoint.
And it also involves sequencing. It has to know that it cannot test the API endpoint before it has updated the database schema. But more importantly, the reason and plan phase is where self-correction happens.
Self-correction is huge. Imagine the model tries a solution, and the test fails. A poor model will just try the exact same solution again, hoping for a different result, or it will apologize profusely and get stuck in a loop.
We have all seen that. Laughs. The model just says, I apologize for the confusion, and then spits out the exact same broken code. That is a failure of reasoning. A strong reasoning model reads the failure, updates its mental model, and says, okay, approach A failed because of a dependency issue. I need to formulate a different plan. Let's try approach B.
This ability to pivot, to absorb negative feedback, discard a broken plan, and invent a new one on the fly is the hallmark of a top-tier agent. It requires a lot of logical flexibility.
Once the model has a plan, it finally gets to the third job, act. This is the part that everyone focuses on. This is where the model actually generates the code, writes the bash command, or formats the file edit.
But even here, ACT is about more than just correct syntax. It is about tool calling fidelity. The harness gives the model a specific set of tools, like a search tool or a file editing tool. The model has to format its request to use those tools perfectly, usually by writing flawless JSON.
If a model writes a genius algorithmic solution but forgets to close a bracket in the JSON command that tells the harness to save the file, the tool call fails. The genius code is trapped in the model's output and never makes it to your hard drive.
Furthermore, the ACT phase requires grounding. The model cannot just invent file paths that don't exist or call internal APIs that were never defined in the codebase. It has to ground its actions in the reality of the files it just read.
Grounding is what stops a model from behaving like a generic textbook and forces it to behave like an engineer working in your specific project. So, action is coding plus tool mastery plus grounding.
Finally, there's the fourth job, govern and communicate. This is the invisible wrapper around the whole process. The model has to follow the overarching instructions set by the harness's rulebook. If the system prompt says, never delete a file without asking, the model has to govern its own impulses and obey that rule.
It also involves knowing when the task is done. A model that lacks governance will just keep tinkering indefinitely, refactoring things that didn't need refactoring, simply because it doesn't know how to stop. It needs the executive function to say, the test passed, the bug is fixed, I am finished.
And it has to communicate back to you, the user. It needs to summarize what it did without overwhelming you with 1,000 lines of explanation. It needs to know when to ask a clarifying question instead of making a dangerous assumption.
Tracking a long conversation, adhering strictly to the harness constraints, stopping at the right time, and communicating clearly. These governance skills are what make an agent feel reliable and safe to use.
When an agent lacks governance, you feel like you are babysitting a brilliant but reckless intern. You constantly have to watch their hands to make sure they don't break something else while fixing the original problem.
When you look at these four jobs, understand, reason/plan, act, and govern, you realize that writing the actual code is just a fraction of the work. The rest of the jobs rely on what we call the sleeper skills.
Instruction following, tool call fidelity, reading terminal feedback, step-by-step planning, and grounding. These sleeper skills are rarely captured by traditional coding benchmarks, which just test if a model can write a standalone script to solve a math problem.
This is why we say benchmark is not agent. It is a useful lens. If you see a model score 95% on a coding leaderboard, that tells you it has a great vocabulary for programming languages. But it tells you almost nothing about its sleeper skills.
A great solo coder is not the same as a great teammate. A great teammate listens to feedback, uses shared tools correctly, admits when they are stuck, and knows when to ask for help. A model can be a phenomenal solo coder and a terrible teammate.
And conversely, a model with slightly weaker raw coding skills but exceptional reasoning, grounding, and tool fidelity can actually be a far more effective agent. It will methodically search for the answer, read the docs, and carefully apply the fix.
So the next time you see a flashy new model release, look past the basic coding benchmarks. The real test is how well it executes the four jobs on every single lap.
To quickly recap, on every lap, the model must understand the environment, reason and plan its next move, act with tool fidelity and grounding, and govern its behavior according to the rules.
Because coding is only a small part of that cycle, a model that dominates a pure coding benchmark might still lack the sleeper skills, like tool calling and self-correction, that make for a reliable agent.
But here is the secret. You can actually take the exact same model and make it behave completely differently by changing the environment around it. In our next episode, we are going to explore why the harness is a remarkably rich layer and how it changes everything. See you then.
And that is a wrap for today. If this made AI feel a little clearer, do us a favor and subscribe. It genuinely helps more curious people find the show.
We are learning and building with AI right alongside you, one episode at a time. So hit follow, and we will see you in the next one.